430 million years ago in the Silurian, hundreds of millions of years before the dinosaurs left their footprints in the mud, the land was a desolate place. But things were starting to change, and life was beginning to leave the sea. Sea scorpions, which ruled the seas as top predators, were capable of leaving the ocean for brief excursions over land. But for life to truly enter this new world, algae would have to grow on land and give rise to plants, requiring soil which did not yet exist. In the deserts of the Colorado Plateau grows something that was critical for jump-starting this transformation of the land: biological soil crusts. These pinnacles of soil are not a single organism, but a small community of microorganisms who work together to thrive in the arid rocky landscape. They are primarily composed of cyanobacteria, which are photosynthetic, making sugar from sunlight. Lichen, which are composite organisms, fungi that live in symbiosis with photosynthetic bacteria or algae, are another important component of the crust. Living among these organisms that build the crust structure are free-living algae that are only active when these crusts are wet after a rain, and fungi that decompose any dead organic material. These organisms bind tiny particles of sand and rock together, while adding organic material, keeping it all in place and not letting it get eroded away, allowing it to accumulate. Like some 400 million years ago, today this buildup of soil allows plants to begin to grow, and modern biological crusts are also made up of primitive plants like moss and liverworts. Today's complex seed plants can also take advantage of these soils if their seeds can penetrate the crust, allowing them to take root in vast desolate sandstone slabs. Despite their importance in allowing life to conquer the land and make a modern desert more hospitable, soil crusts are rather fragile, particularly when trampled under the feet of large terrestrial vertebrates, and recovery from this damage can take years. If you ever find yourself in the red rock deserts of the Colorado Plateau, make sure to stay on designated paths and not bust the crust. With terrestrial ecosystems taking root, animals could begin to inhabit them. The oldest known animal to inhabit the land was a millipede. Possibly one of the steps in between aquatic and terrestrial life are vernal pools, which are rather abundant in the Colorado Plateau. Here, depressions in the ground or rock fill with water after heavy rains. The presence of water activates the eggs of creatures held in a stasis known as cryptobiosis. One genus of crustacean has found this lifestyle quite successful and has existed since the Carboniferous: Triops. These small creatures eat basically anything to let them survive in the briefly advantageous conditions. Its ancestors and many of its relatives, most of which thrive in these ephemeral ecosystems, have been on Earth since the Cambrian. There are also the sister group to Hexapoda, animals that have become incredibly successful since they left the water and conquered the land. Hexapods seem to have taken to the land in the early Devonian, as the biological crusts expanded and allowed for richer terrestrial ecosystems. One of the most numerous soil hexapods today are springtails. These tiny creatures feed on a variety of microorganisms and decaying material, and are called springtails because they can launch themselves into the air away from danger with an appendage called the furcula. These creatures, though, are overshadowed by their much more diverse relatives, the insects. In the early Devonian, the first insects likely looked something like this: a jumping bristletail. These are the most basal insect lineage alive today, with their mouth morphology plesiomorphic to the rest of insects. Over the next 400 million years, insects would conquer the land and sky, and have a great diversity of body shapes. Today, rain in the desert can lead to an explosion of insects, like these swarms of western tent caterpillars carpeting the floor of a riparian woodland. Alongside the arrival of insects, predatory arachnids came to live in terrestrial ecosystems, like this pseudoscorpion, or this fearsome sulpugid. Over time, other groups began to inhabit the land as the harsh, species-poor terrestrial conditions of the late Silurian and early Devonian subsided into the forests of the later Devonian and Carboniferous. With the more hospitable world of the Carboniferous, other arthropod groups join the other soil creatures. Woodlice, which are terrestrial isopods, a group of crustaceans that first appeared in shallow seas only a few million years prior to their invasion of the land. Fish began to crawl out into this world, the ability to escape drying pools of water being highly advantageous, becoming the amphibians. In the deserts of the Colorado Plateau, despite appearances, there are several species of toads. Like the Triops, the rains that fill vernal pools and even stream beds give them a chance to breed. What results is tadpoles, racing to mature into toadlets before their pool dries under the searing heat. Tadpoles are incredibly strange vertebrates, with very distinctive jaws completely unlike the animal they will become. Instead of regular teeth like other vertebrates, they have keratinous teeth and a beak supported by special cartilage that does not go on to form the lower jaw in a toad. This allows them to constantly rasp at algae, feeding continually to push their metamorphosis into a toadlet. This lifestyle, though, is hard to pull off, and in the Carboniferous, some amphibians would leave the water behind, no longer laying their eggs in pools of water that could evaporate away, becoming the reptiles. Today, life on the Colorado Plateau is a testament to how life conquered the land and led to the beautiful biological world that carpets most parts of the planet. Thank you for watching this video. I really appreciate it. On this channel, my goal is to create quality short documentaries that educate viewers on the natural world and hopefully inspire outdoor exploration and conservation action.